Okay, so good afternoon, everyone. Welcome again to today's workshop. Today's workshop will be on leveraging data analytics to inform strategic decision making. And today we'll be having our moderator, Mr. Sunday Moses, moderate this session. But before we move into the session, ground rules, we should also note that this workshop is being recorded and is posted on our YouTube handle for our students to have access to it. So if you want to turn on your camera on your laptop or your phones or whatever device you use in this afternoon, please do well to be professional in your sitting arrangement so that you don't want some dirty laundry being aired on YouTube. Um, so without further ado, I'd like to introduce Mr. Sunday Moses to come in and introduce himself and our speaker. You guys should do well to bring out your pen and your paper like I already have out and enjoy the session. Mr. Sunday, over to you.
Oh, thank you very much, Mr. Victor. Good afternoon, everyone. Good afternoon, Mr. Ibrahim. It's a pleasure this afternoon having to moderate this section. We will be having a very wonderful discussion because the speaker who we have here is actually a very revered specialist in this field, and this section actually promises a lot of insight and value. And I am more than excited to be moderating this section this afternoon. So without further ado, I would go straight into introducing our speaker for the day, helping you understand his background and why he has been chosen to give us this lecture this day to help us understand how we can leverage data analytics in business decision making. Thank you once again for having me. So right into Mr. Ibrahim's bio. Mr. Ibrahim Ahmed is an Ibadan-born IT professional with a broad range of skills across domains like finance, programming, database design, administration and analytics, networking, and cybersecurity. So he has over 20 years of post-qualification experience and holds the following qualifications: an MCP, that's a Microsoft Certified Professional. He's also a Microsoft Certified Solution Developer. He also holds the MCDBA. He holds the MCAD, the MCSD.NET certification. He also holds the OCA certification and also the OCP. He also holds a PMP certification and also a CFOT certification, and lastly, a CEH certification. With all of this loaded value, you would agree with me that Mr. Ibrahim Ahmed is more than ready and are willing to extol impact to us this afternoon. So furthermore, he holds a BSc Hons in psychology. This was in the 1997 from the University of Ibadan. He also went ahead to acquire a Master of Information Science and also a Master of Business Administration, MBA, from the same university. He has undertaken courses at Lagos Business School, IESE Business School, Wharton Business School, Stanford University, MIT Sloan, Harvard Business School, George Business School, Cambridge, and London School of Economics. Mr. Ibrahim's industry experience cut across technology service delivery, management consulting, and the pharmaceutical industry. He's also a manager, information system at Alpha Beta Consulting Limited, and he spent over 6 years at Priest Waterson House Coopers, that is PwC, Nigeria, before joining Sanofi as head of IT and security in 8 African countries in 2011. And since then, he has consulted for donors agency like UK DFID, USAID, World Bank, and top clients across financial services, oil and gas, FMCG, telecoms, and public sectors, and also the real estate sectors of the economy. So currently, he focuses on finance data analytics at global level and is wrapping up his doctorate in strategic management at EMAS, Moscow, and is also a data science faculty at Rome Business School, Nigeria. After reading, this brings us to the point where we're going to make way for our speaker this afternoon in person of Mr. Ibrahim Ahmed as he takes on this platform to unpack all the values that he has for us. Mr. Ibrahim Ahmed, you're welcome. Good afternoon once again.
Thank you very much, everyone. Good afternoon. Kindly confirm that you can see and hear me.
Affirmative, sir.
All right, thanks a lot. Yeah, I'm delighted to be with you, members of the learning community, to discuss this important topic titled Leveraging Data Analytics in Strategic Decision Making. I am the guy that the anchor person has described. This is just a short bio about myself. But just to put it clearly ahead, that the session is going to be for 1 hour on my side. There'll be Q&A afterwards. That'll be part one when I'll be flying through some of the concepts. So you need to pardon me if I appear to be too quick in that first part. It's a way of creating enough time ahead of the second part when there'll be practical demonstration. So we already have hands up from someone. I think we'll get your feedback shortly. You can put your message in the chat box we will attend to it once we have it. So in the second part, there will be practical demonstration of 3 or 4 scenarios for us to be able to see the practical reality of what we are talking about. Then we'll go into Q&A. So just to prepare your mind for what the practical sessions would look like, we are going to deal with this situation where your company has 3 production plants, and then you have 2 warehouses, and there are 3 distribution centers. And we need you to move certain quantity of goods from your production sites through the warehouses to the distribution centers based on some constraints. So the figures you have are 6, 5, 4, 7, 8, 5, and then 6, 7, 9, 3, 6, 12. And the cost of moving each unit of the good from the production site to the warehouse, and then from the warehouse to the distribution center. So we're thinking of how best can you move product from production site P1 through P3 via warehouses W1 and W2 to distribution centers DC1 through 3. That's the first puzzle for us to look at. The second puzzle is going to be a situation where you have observed over time that 70% of customers who bought in a certain month come back the following month, but 30% of them don't come back. But 80% of those who did not buy last month end up buying this month. And then you are given the challenge of estimating how many customers do you expect in your business in the 10th month from now. We would like to see how data analytics could help us answer this kind of a business question. There will be another puzzle where someone has given you an investment idea on, okay, you put in 45 million naira now, and then we are giving you some future cash flows, and we are asking you to think through it and decide whether it's a viable business or viable investment opportunity for you if the discount rate is set at 18%. How do you make this sort of decision as an investor? We will show you how this can be done. Then there is going to be a scenario where you have been given some massive data set by your sales director to analyze based on the last purchase date of each customer, the frequency with which they have been patronizing your business, and how much they've spent buying from you. You are required to classify or group these customers into multiple segments, as marketers would say. How do you go about doing this? There will be another exercise on forecasting. 2 exercises basically, but these are things that I need to put out there. So you prepare your mind for what the practical demo will look like. So I have 2 screens just to put it out there. This is the main screen for my presentation. During the demo, you may see my face turning here, so don't get confused as to the orientation. So let's go into the meat of the day. Strategic decision, what exactly do they mean? Because we're talking about using data analytics as a tool for driving strategic decision making. Everything we do in strategy is about looking at constraints and then trying to optimize those constraints. I hope I'm still visible. No.
Yes, you are, sir.
All right, fine. So we're trying to optimize those constraints. Maybe you are trying to minimize costs. Maybe you are trying to give jobs to a certain number of people and get the highest level of productivity out of them. Maybe you are trying to ensure that goods get to destination within the shortest possible period. Maybe you are trying to optimize the production capacity of your manufacturing outlet. It's always a combination of many constraints. So in strategy, we're trying to come up with the most optimal route to profitability. So the ultimate goal is going to be to maximize your profit by reducing your cost profile. You also want to gain market share. All of these will be geared towards maximizing your profit. So what will your approach be? What are those activities that you need to put in place to achieve all of this? That's going to be the objective of strategic formulations. But you can't do all of that without having data. And that's where the concept of data analytics, comes into discussion. So what exactly do we mean by data analytics? This is not a definition from any standard organization, just something very basic. Whenever we hear data analytics, don't have computer science in your mind. And don't have finance in your mind or statistics in your mind. Rather, you should think of data analytics as a multidisciplinary kind of a field, which combines some of these elements that I mentioned. And the objective is to get data, clean them up, structure them, analyze them, and present them in formats that aid decision-making by different stakeholders, whether within your business environment or outside of it. And then when you think about the different types of data analytics that are out there are basically four. The first one is talking about descriptive analytics. Second is predictive analytics. The third is diagnostic analytics. And the last one is prescriptive analytics. So what exactly do this mean? When you think about descriptive analytics, you are talking about what already happened in the past. So there you'll be focusing on, did we meet our budget last year or not? Did the particular product sell as much as you anticipated or not? So you are describing what already happened in the past, financial year or years, as the case may be. So most of the analytics we do in various business environments often fall within the descriptive analytics domain. When you get to predictive analytics, you are focusing on what is likely to happen in the future. You are trying to estimate what the future will be. And there are many techniques for doing this. Sometimes people think about the past influencing the future, as in what happened in the past will be a reflection of what the future may be. Sometimes it follows that model, sometimes it doesn't follow that model. So you may look at some data set and start thinking, are certain customers likely to buy from you this week or next month? You're predicting their probability of purchasing from you based on their purchase history. This will come under predictive analytics. You may also be trying to set targets for your business and trying to find out if that target is realistic or not. Now, when we talk about diagnostic analytics, we are talking about why did we experience what we just experienced? So if we make budget, for instance, diagnostic analytics will drill down into our data performance and tell us, okay, Esther, we can see your hand up. Any issue, please? Okay, maybe you should just lower the hand. We'll take all your questions when we get to Q&A, please. So diagnostic analytics will focus on why what happened, just like I said. So if you look at sales performance, it can tell you, why did you meet budget? We aren't just talking about we exceeded our budget for a given, financial period. Maybe it was just a windfall from one customer that made you win, and not like you were on course to win. Diagnostic analytics can tell you that. And if you didn't meet budget also, diagnostic analytics can tell you why you didn't meet your budget, in which state did your performance fall short of the expected level, which product portfolio did not deliver on its mandate, for the financial year. Diagnostic analytics will give you all of these details. But when you set target for yourself and you are thinking of how to achieve it, prescriptive analytics will give you an idea of how to achieve what your objectives are. And that's why we call it prescriptive analytics. We are prescribing different paths to achieving your goals to you. In today's demo, we will showcase virtually all of these 4 types of data analytics options, and then we'll see how they impact us in our different work environment. But we cannot be talking about data analytics without having a basic understanding of how data gets to the stage where we start, analyzing it. And that's where the concept of data pipeline comes in. Now, forget about the intimidating nature of this diagram. The message you need to pick here will be as follows. 1, we need to capture data from multiple sources. Some of them may be internal, some may be external, and most times you may need to blend the 2 sources. But in real life situation, you have data from within your business, and then you have data that you rely on from external sources. When we ingest all this data into our own infrastructure, we need to clean them up, and then we will tell you we are doing an ETL operation at that stage. We're extracting, we're transforming, we're loading. And then we load data into a lake, a data lake, which is going to be a simple site where data comes in from multiple sources. We do some additional transformations and keep our data in the warehouse. And after that, we will make the data available to analysts who want to start, producing all sorts of reports and visuals for management or other stakeholders to see. So from capture through analyze, the bulk of what they do there is what we call data engineering. And once data has been appropriately engineered, people who are using it will just be connecting to the data warehouse, and then they can analyze the data using Excel, Tableau, Power BI, or whichever tool they may be familiar with. So the people who do capture through store are usually behind the scene. Same thing with analyze to some extent, and then those who use the data are the ones that management people often see as complete analyst. So what are the basic skills required for you to work as a data analytics person? There are just about 8 basic skills. You need to understand basic principles of probability as we were taught in maths in secondary school, nothing more than that. Your knowledge of statistics should be pretty okay. It doesn't mean you hold a BSc in statistics. If you understand mean, median, mode, standard deviation, variance, how to test, hypothesis, that should be good enough. Very important is element 3 here. Your knowledge of the business must be very sound. It's not good enough to have tech skills and you don't understand the business. You will always fall short in your analytics, and that's not going to be good enough. So if you're not a programmer, you can also do your analysis on spreadsheet using Google Sheet or Excel. So most of my demo today will be in Excel environment, just to show you that you don't need to be a Python programmer for you to be involved in data analytics. But if you want to be a top analytics person, I recommend you learn SQL, that's structured query language. It's a way of talking to databases and setting them up. You may also need to learn Python or R, or you may learn both, depending on how flexible your time is. You need to learn how to display data using Tableau, Power BI, or Excel. I'll use Power BI to do a demo later today. And some basic knowledge of algebra and econometrics may be necessary. Otherwise, you'll be depending on too many people to get your job done. So having said all of this, let's review some 9 cases where people often use data analytics in no sequence of importance. I'll start with investment viability. I spoke about it earlier. So what exactly do people do here? One of the techniques they use is what they call net present value. And the formula may look intimidating, but we'll demystify it when we get to the demo. The objective here is to look at series of future cash flows involved in your investment, horizon from the beginning to maturity. We will discount them to the current value based on the discount rate prevalent within your economy. And then when we add all of these discounted values together, we will get a result called the net present value. So the objective is to say that if your net present value is greater than 0, meaning that it's positive, then it means you are going to derive value from that investment. So the recommendation is that you should invest. If the NPV is negative, then it means it's a bad investment and you shouldn't even think about it. But if you compute your NPV and you get 0, then it says the investment is neither good nor bad. Maybe you need to investigate more on some of the cash flows that you use, and you may be able to tilt it either to the positive side or the negative side. There will be a demo on this. Then there is a second use case which deals with transshipment problem. Let's think of a situation where you own a factory or 3 factories, 1, 2, 3, and you are moving products through warehouses A and B to project site 1, 2, 3. Each path that you see, movement from factory A to warehouse A, factory 1 to warehouse B, there are costs to moving products on different routes. So we are trying to optimize the process such that we minimize the total costs required to move certain quantities from the 3 factories to the 3 project sites based on the demand. So this is a demand supply situation. How do we go about doing this? We will solve this problem when we get into the demo situation. But just to put it out there, that there are instances when movement may be more complicated than you have here. It's not in all situations that you move from factory 1, for instance, to warehouse 1, warehouse A and warehouse B. There may be situations where you produce from factory 1 and you move those products to factory 2 because it may be cheaper for you to go through that route before getting to warehouse A or B. And there may be situations where there will be maximum constraints on what you can move along certain routes or paths. But we will keep it simple. We won't go from one factory to another. We won't go from one warehouse to another. We will just assume you are going from factories through warehouses to your project site. How do you solve this sort of problem using data analytics? We will demonstrate that to you. Salesmen often have a problem. You have a situation where you are leaving home in the morning. You need to touch base with, like, say, 20 potential customers of yours. And the route they have different costs attached to them. So in TSP, or traveling salesman problem, what we are trying to do is to minimize the distance we travel between our leaving home and then returning at night. We often do this in our mind. I know, okay, I'm leaving home in the morning. Let me get to Ojuelegba first. Then from there, I come to Ikeja. From there, I go to Maryland. From there, I go to Yaba. We plot this in our head. It shouldn't be our headache if the figures are known. So once we know the cost of moving along different routes, cost in terms of difficulty of traveling, the timeline, traffic constraint, risk associated with moving on that route, all of those things go into computing the cost. How best can you move from your origin through all your destinations and back to your origin by minimizing the time spent and the distance traveled? TSP puzzle is there, and people use data analytics to solve this kind of problem. For marketers who have customers out there that they're trying to. Yeah, please, Onokwe, please help us mute your mic. Yeah, please. Onokwe, please. So we have marketers who are trying to segment customers, or salespeople may also be trying to segment customers based on all these 8 parameters. How do they go about grouping customers into different buckets so that you put people who are similar to one another in the same segment, and you can target them with appropriate messages, give them the kind of products that suit their profile, rather than targeting people who are on the high end with product meant for low end people. Data analytics can be used to achieve this in a very seamless manner. There will be a demonstration of that to us in the practical session. Sometimes you use data analytics just to show which of your channels are performing the most. Maybe it's your store, people come in directly to buy through the store, or it's your web channel that is doing performing the most for you, or people buy basically from mobile channel, or it's through social media, or they need to make phone calls. So you can analyze your sales based on the different channels that are available. It may even be a case of payment. You may be checking which payment channel works most for you. Is it USSD? Is it check? Is it bank transfer? Is it card? You are analyzing all of the channels available and then trying to see which one drives your business the most, and then which one you should concentrate on and which one should de-emphasize attention on. So when people think about multi-channel form of engagement, you may have it this way. Each channel is not dependent on the others, but in an omni-channel business model, they're having interaction across all of the channels, and then you can still estimate what is going on at each channel level and how one channel impacts on the other. But data analytics can give you solutions. Please. So your objective here when you do channel analysis is to reach your customers as much as you can, act on their needs, convert some of them into advocates of your product or service. Of course, you want to engage them. You want to be in their faces. You want to, give them what they want, and then retain them as much as you can within your business environment. Data analytics can give you this kind of opportunity. There are instances when you need to check the worth of different customers to you using what we call the RFM analysis. This is a situation where you are trying to check the recency of transactions involving different customers. When was the last time they bought from you? You cannot value someone who bought 3 weeks ago, last week, and this week the same way you value someone who bought 6 months ago. So recency could be used to group customers on the basis of how recent they bought. You may also think about the frequency of purchase. Some people may be buying recently, but they're only buying 1, 2, 3 units. Meanwhile, someone bought, many products some months ago. So you need to think about how often they come back to buy from you and use that to profile customers. I may be buying every now and then, and I'm spending 100 Naira with you. You cannot class me the same way you class someone who bought once or twice and spent thousands of Naira in your store. So we may need to factor in the monetary element when we are doing customer analysis using RFM techniques. There's going to be a demo of how this can be done. Data analytics shows you this, and it's going to be very beautiful demonstration. Then you may also do customer cohorts analysis. This is use case 7. This is a scenario where you are looking at frequency of purchase, but in terms of their recency. Let's say, for instance, we have these dates of transactions on the left-hand side called the cohorts. And we realize that on April 27, 2014, 79 new customers came in. And then on May 4, 168 customers, new customers came in. And you go on up to August 24, or whichever timeline you are looking at. Now, let's look at that first row, April 27, 2014. Of the 79 customers that were new on that day, only 22% of them came back the following month. Only 19% of them came back 2 months down the line. Only 13% of them came back 3 months down the line. And so on and so forth. So you can use customer analysis to show how often do your customers come back to buy from you. And if you want to see which group you should focus on because maybe they dropped off at some point along the line, this sort of analysis will tell you, oh, we've not been retaining the customers that came in newly at certain point, and we need to engage them for that. You may not be able to use Excel directly for this, but it's possible for you to get this sort of visualization using customer core techniques. Excel can do it, but there are more suited tools for that. I have a demo on that when we get into the practical session. Then for forecasting, another use case, that's use case number 8. Forecasting is a way of saying we know where we are, we have an idea of where we want to be, but we don't know whether we'll be there or not. Can we get to a particular destination if certain assumptions are laid out? Yes. So for this sort of an analysis, you may say, I'm looking at my performance through June through December of a given year, 2019. Where are we likely going to be in year 2020? So you are forecasting. Most times people will just forecast by using trend analysis. It works, but it's not foolproof. There are techniques for doing more meaningful forecasting, which we will see on the next slide. But just as a way of mentioning here that you can forecast so many things. You can forecast weather, you can forecast sales, you can forecast demand, you can forecast market movement in capital market. You may be able to forecast stock prices to some reasonable degree of accuracy, and you may equally forecast house prices depending on whichever industry you have. You may even forecast the ability of people to pass exams based on historical records and a number of other parameters. But basically, these are the techniques that people use when they forecast. It's a whole, a lecture on its own. We are not going to dive too deeply into this. But suffice to say that in today's conversation, I'll demonstrate to us simple linear regression and multiple linear regression, which are methods quite different from what Excel will normally give you when you are doing trend analysis, which is just a way of saying what happened in the past will influence what's going to happen in the future. Or you are using moving average of say, okay, sales of the last 2-3 months, if we average them, we should be able to say that's going to be our sales for next month. Or some people will do 4-month moving average or 5 months moving average, depending on the reality of your different business context. But these are methods that people often use. If you go into one step above on that Delphi method, this is where you ask some experts to forecast for you, and you run some tests within experts and say, oh, Ibrahim, expert 1 told me this is his forecast. Would you like to adjust yours? And I may keep my forecast or adjust my forecast based on what someone else is saying. At the end of the day, there'll be a consensus among experts, and then you may use that as a way of forecasting. There are a number of techniques that people use for this, but we are not diving deep into that because that's a whole body of lecture on its own. And I think my last use case here is what I call state-based predictions, which we use Markov chain to solve. Let me slow down a bit because this one requires a bit of explanation based on the numbers that we are seeing here. But take it from me, it's very simple. Let's assume there are 2 possible states when you're forecasting weather. I know in reality it may be more than that because there could be 3 states, sunny, cloudy, or rainy. But let's assume it's 2-state situation where we can have a sunny day or a cloudy day. Now, when it's sunny today, then there is a 20% chance that it's going to be sunny tomorrow. That's what this red arrow is talking about. And that means that if there is 20% chance it's going to be sunny tomorrow, it means there is 80% chance that it's going to be cloudy tomorrow. But if it is cloudy today, there is 60% chance that it's going to be cloudy tomorrow. So it means the next day, there is 40% chance that it's going to be sunny. You are mainly inferring this 40 and 80% from the values of 60 and 20% that you have here. So if you have a situation like this where you can estimate the probability of states changing from one state to another, then someone can ask you, 2 days down the line, is it going to be sunny or cloudy? 7 days down the line, what is the probability that it's going to be sunny or cloudy? You can use a Markov chain technique to solve this kind of puzzle. So the assumption that we make here is we're not looking into the history. Rather, we are looking at what is happening today alone. Today determines tomorrow. Yesterday does not determine tomorrow. Rather, it's just today. So people can use Markov chain approach to solve problem. And here we have two states. That's what I have: state space, sunny and cloudy. Markov assumption is just what I've given you as today influencing what happens tomorrow. The transition diagram is the diagram that we have drawn on the screen. And the transition matrix is going to be this TM here. So let me walk through this matrix for you. If it is sunny today, then it means it is 100% certain that it's sunny today. And then that means cloudiness as a condition is going to be 0. So that's why you have the initial state of 1 and 0. But because of this matrix that have been given to us, or series of probabilities that have been given to us, we can construct a transition matrix and say, if it is sunny today, imagine an S being here. Sorry, let me go back. Let me activate my pen. So imagine an S being here. And then a cloudy state being here. S being here, cloudy state being here. So we are saying, if it is sunny today, what is the probability that it will be sunny tomorrow? It's 20%, that's 0.2. If it is sunny today, what's the probability that it will be cloudy tomorrow? That's 0.8. That's this. If it is cloudy today, what's the probability that it will be sunny tomorrow? That's 0.4, this 40%. And if it is cloudy today, which is this, what's the probability that it will be cloudy tomorrow? This 0.6. So this is your transition matrix. It will always be static along the line. So the rule in Markov chain is that the next state that you are going to have, which is going to be the state for tomorrow, will be the current state, which is this S0, multiplied by the transition matrix. So if for tomorrow someone is asking me, what's the probability that it will be sunny? That's going to be S1. So this is today's state. This is the transition matrix. And when you do the multiplication of these matrices, you will get this. So I know this is going to be sunny and it's going to be cloudy by 80%, probability. If you go to state 2, which is going to be 2 days down the line, you can bring to tomorrow's state, which is S1, which is this, multiplied by the transition matrix. Then it tells you 2 days down the line, there is 36% chance of sun, having being a sunny day. And then there is a 64% chance of having a cloudy day. And it can continue to go in that chained approach day after day. And that's why people call it the Markov chain technique. So how can people use this sort of technique in a real world situation? It's very easy. You can use it to predict stock market movements. If from experience, if the market moved in a bullish scenario today, then most of the time it will also be in a bullish mode tomorrow, meaning that things are picking up. If you gather such data, you may be able to predict movement of stock market using Markov chain. And it may be a bearish scenario, in which case, market is going down based on observed pattern. We may use it to predict health modeling situation. For instance, when you go to teaching hospitals, and doctors may not want to admit you immediately because they don't have enough space in the wards to keep patients. But if they use Markov chain approach, they may be able to estimate how long does it take patients to stay within the ward before they are discharged, and they can use that as a way of optimizing the way people come in and go out, and ensure that there will always be enough beds, for people to use when they come in, rather than bouncing them on the ground that they don't have beds or bed spaces in the world. Please help us mute Faith Ibrahim. Now, people can also use this to, model market penetration. If I know the way people get the message, the marketing message that we pass to them, we can estimate after a certain number of weeks. Can estimate after a certain number of weeks and months how much of our message has reached the critical mass of our target audience, and how much of them will be buying our product. People can use this to, schedule production planning in corporate environment based on the movement of the products in the distribution pipeline. For instance, if I know the rate at which the production plant pushes products to distributors, and I know the rate at which distributors push products to wholesalers, and wholesalers push to retailers, and consumers buy, then we can plan our production schedule appropriately so that we don't flood the distribution chain with products and then, cause problem for our own company. Markov chain, solves that sort of situation puzzle for us. So let's go into demo. I think I've kept to 36 minutes for my theory. The next part is now going to be more of demo. This is going to be demo number 1, investment viability analysis. Someone has introduced to you this option, which requires you to spend 45 million naira at the beginning, but next year you're going to have 17 million, year 2 you have 25, year 3 you have 10 million, and so on and so forth. Is this worth it or not? Let's check how this plays out. I'm going to switch to my Excel screen. Confirm if you can still see my Excel screen now.
Yes, we can, sir.
All right, thanks. All right, so I've laid out this template here. I've laid out this template. I've brought this same formula here just to guide our conversation. This is the discount rate, which I put in here. You can take it to be the inflation rate in your economy. At the initial stage, you are spending 45 million naira. That's there. But subsequent years, this will be your cash flow. There are 2 methods for solving this NPV issue, but I'll solve both methods and then show you what the steps are. So the first thing you should do will be the discount factor, which is this 1 plus I raised to power t, where t is the year. So I have denoted them as the timeline here, 0, 1, 2, 3, 4, 5. Those will be the values of your t, and I will be the discount rate. I have named that cell as D rate. So in case you see D rate in the Excel file that will be shared with you, so don't start thinking like, oh, where is D rate? D rate is standing for cell D2 in this. So the first thing I'll do is to say, what is the 1, I'm putting the formula, 1 plus D rate raised to power T, which is this. So it gives me 1 for that first year. And I can easily double click here and I'll see the discount factor for subsequent years. That's step 1 here. Step 2 will now be to discount this cash flow, which is RT, for different years. This is a way of saying 1 naira today is worth more than 1 naira 1 year down the line. So don't always think like, oh, Naira has the same value all through its life cycle. No, time value of money concept comes in here. So this is going to be is equal to your cash flow here divided by your discount factor. And then you still have a negative outflow of 45 million naira for year one. And I can do this, copy the formula, add the discounted cash flows for future years. So when I get to method one, my NPV will be the sum of all these values here. And it tells me it's 5.79 million naira, meaning it's a positive NPV, which suggests that it's a viable investment opportunity and I should go into it. But what if you do not want to use this long approach? Excel has an NPV function, which is built into it. So it's asking me, what is the rate that you are using? I'll say it is 18%. Where are the values that you are trying to focus on? This time around, I won't focus on discounted cash flows. Rather, I will focus on my values for years 1 through 5. Don't include year 0 yet or the timeline 0. So this is what I'm going to do. Then I will add my initial investment into it, and I should have the same result. So these are two methods that you can use to calculate NPV, and you are pretty sure the results will always be the same. And the interpretation of this is it's a viable investment opportunity. You should consider, investing in it. How about if the discount rate is higher than this? Let's say it's 26%. What are you going to have? It messes the scenario up. It's no longer a viable investment opportunity. So don't dream that, at 18%, it looks good, I jump into it. In Nigeria, I don't think the discount factor is 18%. So this approach at 18% won't work. I think MPR should be something closer to 2%. Sorry. And if you put in the reality of 27% here, then you are drowned as an investor. So think about that. One last comment on this is the fact that in reality, you may not have the discount factor being 18% for all of the years. So each year may have its own here, which is the discount rate. So you may need to adjust your formula such that each year will use its own specific discount rate if the discount rate is unique for different years. But generally speaking, people just throw in the same discount rate for the entire timeline. But in reality, that may not be the situation. Some years may have the same discount rate. Some other years may have different discount rate. That is the demo here on investment viability. Let me go to the next demo. Just 1 minute. So this is the solution. You have the Excel file and then you can play with it. Now, the second demo here is going to deal with customer analysis using RFM technique. This is recency, frequency, and the monetary investment. And you have 581,000 customers. How do you go about doing this? I'm going to open a file to show this. Just give me a moment. Where is my file? All right, so confirm that you can see my Power BI screen.
Yes, we can see it.
All right, thanks a lot. So what I have done—
We can see.
All right, before you came in, I've imported the data into Power BI. I did some maneuvering. So this is the entire data set that I was alluding to, 824,000 rows specifically. And then we can see the invoice number, the stock code, the description, all of the necessary columns are here. And what I did was to say, okay, bring in something, create a new table for me. I have all of the unique customer IDs in one column. So 5,943 customers exist in this data set. So I did a DAX function to indicate when was the first time every customer bought anything from us. So this first order date is here. And from that, I could derive when was the first month and year that they bought from us. Then I did another DAX formula to calculate the last month or the last date all these customers bought from us. And then I could, on the basis of that, get the last month and year when they bought from me. Of course, if you are using your own approach, you will be using this versus the current date. So your figures may not be as high as some of the things that I will have here. For instance, when you look at my recency value, I'm comparing it to today. And these were transactions in 2010, 2009, 2011. So you see the last time this customer 17850 bought from us was 4,914 days ago. And then I did a maneuvering to say, okay, this column serves, that purpose. I can see when was the last time, the number of days that any of these people bought from me. I can see what was the frequency of purchase when they were buying from day one to the last date. How many times did they come into my store to buy? That column is here. And how much did they spend in whichever currency you are considering? That column is there. Then I came into a column and call it R score and said, based on the number of data that I have in my recency column, it should split them into percentiles. And it says here that if you have bought a less than, so if you are very few, say 20% of people, if you are bought in like, say 20% of
Hello.
We can hear you now, sir. You are back online.
Can't hear you, sir. Can't hear you.
I can't hear you.
I think his network kicked him out.
All right. Okay. Thank you so much, guys, for. Okay, Mr. Ibrahim will be back soon. We are trying to reach out to him here. I think his network is not so good, but he will join us briefly. So before then, some of us that have questions, I think we can do well to drop it at the chat box. Yes, you can do well to drop it at the chat box. And let's also do well to jot down some questions for some of us that would like to ask questions. And before the end of the workshop, we'll be sharing a survey. Is also an attendance. So I see a lot of persons that are saying share the recording and the slides and the Excels. So please do well to fill the survey.
Sorry, good afternoon. Did you say you were trying to reach out to?
All right, so please do well to fill the survey. It will help us to track your email and forward the recording to you. Thank you so much. Emmanuel Edward, I don't know.
Hello.
Yes, can you speak?
Yeah, I have a little complaint. The timeline at which we get this recording to our mail and or to the video uploaded in the website, it doesn't used to come immediately in such a way that we can download it on time. Because one thing lead to another, you might not come back easily before you know the 2 weeks is gone and you not see the audio there again. And a lot of us, not only myself, a lot of us has missed on having a copy of the audio. So I want to appeal and plead with you, the didactic, to assist us, and then maybe a share of the whole audio from the beginning of the class, of the session, so that all of us will really want to have it. Thank you.
Okay,
I think
so
it's usually sent to your email.
No.
We don't get
Alright,
recordings.
so for the
I
recording,
think
hello.
that is why there's an emphasis.
For the recording, you share it to emails. Please fill the survey, you get the recording. It doesn't come out immediately. And most times we have to wait for the speakers to forward the slides to us for us to share it alongside the recording. So if you want to get it, make sure you fill the survey that we'll send across before the end of this webinar. Thank you.
Yeah, I'm back.
Can we have the survey sent, because we can't see any survey?
It will be sent. It will be
100%.
sent. Welcome back, Mr. Ibrahim.
Yeah, thanks a lot. Apologies for the technical glitch on my own side here. Myself. All right, thanks a lot. I'm back here. So what I did was to compute my score for recency based on percentile logic. I did the same thing for frequency. I did the same thing for monetary scores. And then I multiplied R score with F score and M score, and then got the RFM score. And then I was able to use what you call if statement. We call it switch statement in Power BI to rate different RFM score. And I got ratings of very good, excellent, average, low, very low, based on the metrics that I came up with. But the final result is what you will find on this screen. I used a control here called the tree map to group all of the 5,000 plus customers into the different buckets based on their RFM score. So I can see 1,135 are excellent, 935 very low. And then I can see how much money each category has brought in for me. In terms of frequency of purchase, I can see what each category is doing. I have a table here showing me the distribution of all these categories per country. I can also look at it on the map, and I have all the customer IDs here. Now, the beauty of this is that if I want to look at these 8 customers from Sweden who are low, I don't have to start looking for Sweden on my map here. I just click on this figure 8. And then the report changes and I can see those 8 customers. I can easily focus on them. If you just want to focus on people who have been excellent based on their frequency, you don't need to go that route. I can reset everything to what it was, and I'll click on this bar and I'll see the summary here. 1,135, I can see the distribution per country, and all sort of insight can be derived from this. The recency bit on the customer cohort that we mentioned earlier, I have the details here as well. This shows you when different people came to buy and how many of them have been coming back month after month. And you can see those people that you need to focus on in terms of, messaging. This is a possibility when you are using RFM analysis. This is RFM analysis here. This is cohort analysis being used in here. Let me quickly go back to my slide to check which one is the next demo. So this is how I went about solving this. I didn't use 4 buckets. I used 6 eventually, and this is the result. Now, when it comes to regression is a way of saying, let me compare 2 variables. I have a file here. I'm comparing 2 variables, X and Y, In this case, it may be how many people do you need to contact on a daily basis before you make some sales, and you want to set up the relationship between X and Y. Most times people get confused when they get here and they don't know, okay, if I meet 63 people, what is my sales likely going to be? You want to be able to predict that, but you can't just predict unless you establish a relationship between these two variables. So how do you go about doing that in Excel environment? You need to go to, first and foremost, you go to File, you go to Options, you go to Add-ins, and then click on Go. And then you select Analysis Toolpack. If you don't have it selected, then you check it and then click on OK. But for another example that we're going to have, you also need to click on Solver and click on OK. I already did that, so I don't have any problem. And that's why under my Data tab, I have Data Analysis in here. So if I click on Data Analysis, I don't need to have my record selected to do this job. I can click on just any cell. And if I click on Data Analysis, I'll come in here and say, I want to have a regression analysis done. I'll click on it, and it's asking me, where is the input range for my Y? I know this is the input range for Y. How about my X or my input? In this case, I have just one X. I'll put it there. And then here, I'm indicating that I selected labels. Labels will be X and Y, as the case may be. And then it's asking me, where do you want to put your output? I'll put my output on cell E3. Sometimes people may put it in another worksheet or another workbook. It depends on what suits them. So these are the basic parameters that you set in here, and you click on OK. And then Excel goes ahead to come up with some of these stats for you. Don't get too bothered with what it has brought out. What it's telling you essentially is that if you come to this side and you're looking at the coefficient, just a minute. If you're looking at the coefficient, I'll highlight the key parts here. It's saying focus on this, focus on these two, and then you may also need to focus on this. Now, what this is telling me is that my model will be Y is equal to, Y is equal to, you know, normally in mathematics, they will say mx plus c, the equation of a straight line. But in this case, my Y will be equal to the m here is going to be 10.3x plus 300 plus 0.9. So you may be wondering, where did I see 10.3? I saw 10.3 here. That is the coefficient of x. And then the intercept on the y-axis is 300.97. So if you use this model to predict the next y given an x, you will be able to estimate the result within high degree of accuracy. But when you look at the reliability of your model, this R square is telling you that we can only predict up to 52% of the situation. But if we use multiple R approach, at best, we are getting 72% reliance or reliability of our model. But we can have another, big conversation on just this topic alone. But this is the way you can use Excel to do it. What most people often would do without following this approach is to select these two guys and then go to insert, and then they put a line chart up. I can put up a line chart. Let's do this. Where is it? This is it here. I can put up a line chart, and then this is not going to be, I don't need this second one. I can put up a line chart and then start asking it to give me an idea of what the model will be. So you can say add chart element. You can go and see, I have the line, I have my legend, I have my data label, yes, chart title, axis. I can put up an equation in here later, and then it will tell me what exactly is happening to that particular model. And then I will see that it's going to be exactly what I have given you in here. So this is a scenario where you are using one predictor to predict another variable. That is a scenario where you can use multiple predictors. In this case, I've come up with 3 to predict one other variable, because in life, we don't always have one predictor being used to judge another one. You can use the same approach. Go to your data, click on data analysis. You are doing a regression analysis. Your Y range will be this. Your X range is going to be this, 3 columns. We want the output range to be let me select my X range appropriately. This is going to be my X range. Then my output range, I can put it in here. And then I click on OK. It will give me a similar set of results, and it's telling me the coefficient of X1 is going to be 7.24, coefficient of X2 will be 4.07, coefficient of X3 is going to be 149.38, and my intercept will be this. So we are saying here that Y is equal to 7.24 X1 plus 4.07 X2 plus 149.4 X3 plus 253. If you use this model, you will be able to estimate Y given different values of X1, X2, and X3, because that is what this model, the regression analysis, has shown. And it's telling you you have between 61 to 78% level of reliability of this model. That is another demo that I need to put out there. And just maybe because of time, I'm going to throw this last model out, because we had this scenario where we were saying you have 1,000 customers, 70% of who, if they buy 1 month, they come back the following month, and 80% of the 30% that didn't buy may end up coming back subsequent month. How do you go about solving that problem? The solution is right here on this screen. Let's say you have active customers and they can transit into being inactive. Over the time, only 30% of them drop off subsequent months. 70% still come back. But of the 30% that dropped off initially, 80% often come back to you and 20% remain inactive. So the question then was, 10 months down the line, how many customers are you expecting to have in your shop? I came up with this initial state scenario. When all of them are there, you have 1 being active, 0 being the state of inactivity. And your transition matrix will be 70 for those who will come back as active, 30% don't come back. Of the 30% that didn't come back, 80% will come later, 20% remain inactive. When you use this transition matrix to do your multiplication, eventually you will get this result that I have here as state after 10 months. Is going to be this. 73% of your customers are going to be active, 27% are going to be inactive. So if you apply 73% to 1,000 customers, you will have 730 of them expected to come to your shop or to your store or to your business after 10 months. This is the way we can use Markov chain to solve this problem. And then the last one here has to do with transshipment. We laid out the framework for the number of products that are moving from production plants P1 to P3. going to distribution centers, DC1 to DC3 via 2 warehouses. And the matrix is what you have summarized below here. But the easiest way to translate that is to draw a diagram like this. It will show you the different sources. In this case, we have P1 through P3. We are moving 600, or let's say P1 has the capacity to produce 600. P2 has capacity to produce 500, and P3 has capacity to produce 700. There is no constraint on W1 and W2, but there is a demand of DC 350 from DC1, demand of 600 from DC2, demand of 800 from DC3. So how do we go about solving this problem? You need to ignore the constraints of movement from P1 to P2 or P2 to P3, or likely movement between W1 and W2. What I did was to use Excel to solve this problem, and this is the result that I got. A number of people may be wondering, okay, Ibrahim, how did you arrive at this result using Excel? I'll do a quick demo of that and then come up with my Excel results on this. Just hold on a second. Okay, so let's go back to my Excel. I'm trying to switch my screen. All right, so this is my Excel file. I'll go open, it's called transshipment. Yeah, so this is the transshipment worksheet. Let me try to increase it a little bit. This file is going to be shared with attendees. So what I did was just to put in the different costs there. No formula in this case. This is the case or the fact as stated. Same thing here, fact as stated. Wherever you see light blue background like this, it means that it's a formula there, just like you have in here. So the formula here is sum these cells together to see the total movement from warehouse 1. Then sum these cells together to see the total movement from warehouse 2. And then if you sum these two together, which is what you see here, it will indicate the total movement from plant 1. And then down to plant 3, you have the formulas in here. Then we can see movement from warehouses down to distribution centers added in this format. And then you have this one here. So how do we know the results that will be in this environment? Because this is what we are told to solve. How many do I move from plant 1 to warehouse 1 and warehouse 2, plant 2 to warehouses 1 and 2, plant 3 to warehouses 1 and 2? And how do I move those products from those 2 warehouses down to the distribution centers? Those are the puzzles that we have at hand. So I put in a formula here, which you can see. It's just a way of saying, I need to multiply the quantity being moved, let's say this one, by the cost on that route. If you move anything on any route, you need to do the multiplication of the quantity of what you are moving by the cost on that route. That's just what this formula is. And it's still showing 0. So how do we solve this problem? Using Excel. Yes, people can write Python program to solve this, but I'll solve it using Excel here. So we'll go to data. This is where the tool here called solver comes in. Remember, solver shows up because you clicked on file, went to options, clicked on add-ins, you clicked on go, and I put solver add-in. So I need that solver tool here. So I click on N2 and click on solver. So it's asking me here, what is the goal of this result? Where do you want the goal to be displayed? I'll say the goal is going to be displayed in this particular cell. And what exactly is the goal? I'm trying to minimize the cost. I need to minimize the cost of moving those goods across the different chains. So it's prompting me here again. What exactly are you trying to change? Which are the variables that you are trying to change in all of this? I am trying to make changes to those variables in blue. Okay, dark blue now. So I'll say, I need you to change these variables and then these variables. That's all at this level. Sorry, comma, there are 2 of them. I'm changing these two groups of variables. Okay, so I have indicated that, but I am changing them subject to what? I need to add my constraints. So there are three constraints that I have here. Let me quickly make this reference. So constraint number one is going to be like this particular H13 to J13. That's my constraint number one. Let me go in here. This one. This constraint here, this shipment must be equal to, this is what I'm setting here. It must be equal to this result here. This is a way of saying whatever is shipped must be based on the demand that has been made. We cannot ship more than what has been demanded. That is the first constraint. We add that. We need to go into the second constraint, which is according to my prep fact here, H6 to I6. So this is H6 to I6. This is the shipment from warehouses must be equal to what is obtained from K11 to K12. Sorry, this is going to be this. H6 to I6, this is this must be equal to this. I'll add that. I have one more constraint. It says J3 to J5, which is this, has to be less than or equal to K3 to K5. This explanation here is saying, no, I missed it out. Just 1 minute. J must be equal to this. Yeah, the explanation of this is that whatever we are shipping from the production site must be less than the capacity of those production sites. So if I click on OK here, and I say there is never a scenario when any of those variables will be negative. Here, there are multiple options. I pick this simplex model and I click on solve. If I have set my parameter correctly, I should find a solution. Yeah, it comes up with a solution here and it's telling me I'll spend the least. I've used Naira to the, as my currency here. And what it is telling me is that from plant 1, I need to move 300 trucks to warehouse 1. I need to move 250 trucks to warehouse 2. From plant 2, I need to move 500 trucks to warehouse 1. I shouldn't move anything to warehouse 2 because that would not give me an optimal solution. It's recommending that I shouldn't move anything from plant 3 to warehouse 1, but I can move 700 trucks to warehouse 2 from plant 3. And then from warehouse 1, I shouldn't move anything to DCs 1 and 2. Rather, I should move 800 to DC 3. And then from warehouse 2, I should move 350 to DC 1, 600 to DC 2. I shouldn't move anything to DC 3. When we look at this result, we will realize that the total product moved is going to be less than the total capacity of the 3 production sites, and it will match the demand from those 3 sites. This is the way one can use Excel to solve this optimization constraint problem that people may face when they are dealing with transshipment problem. So at this point, I would like to yield back to the organizers. If you need more demos of situations like this, time is not a friend. Apologies for the technical itch. You can join Rome Business School, and I'm here now to take your questions, and I'm really grateful for having you people around there. Thanks a lot.
Wow. Thank you very much, Mr. Ibrahim Ahmed. I can't say of a short that this is more than value packed in one section. And we are grateful for this learning experience. And for my fellow colleagues, I understand a lot of persons have said that they are not familiar with mathematics and math is quite difficult for them. But I think one of the things that stood out for me was the fact that you don't necessarily need a programming skill for you to carry out your data analysis, right? So with basic spreadsheet applications, you can actually go ahead and perform very complicated analysis. Thank you very much, Mr. Ibrahim, once again. And we're going to jump in straight to the Q&A because we've actually spent so much time on this section, but I think it was worth the time actually. So I have a couple of questions here for you. And this is my question actually. And as a student of data science at Rome Business School, I understand that most times when we get to talk about data analysis, or when we get to have this kind of section, a wide range of our audiences are people who are probably at their beginner level, or probably are enthusiasts, right, seeking to jump on this career role. So I would like to ask, because this is more like a very practical section that was not based off on theory, but then a combination of theory and then practicals too. So I would like to ask that how can a startup, for instance, now, which oftentimes we know are bedeviled with limited resources, now effectively collect data, analyze this data, and then make informed decisions out of this? Because we know that for you to have a perfect a decision from your analysis, you must ensure that your data are actually very accurate, because that is what is going to influence your decision. So we know this is also cost consuming. So for a startup who is probably just starting out and then trying to manage resources, how would you advise that we go through the process of data collection, analysis that would guide our decision making?
Yeah, thanks a lot, Sunday. It depends on the approach you want to take, but the general idea is to use two possible sources for your data. You may rely on someone to gather the data for you, in which case you are dealing with primary data from someone, which is going to be secondary data to you. And you bank on the credibility of that, agency to have done an amazing work in doing all of the good work to give you accurate data. If you're not doing that, then you need to be the one gathering the data on your own. So you may launch survey and then gather the data from the field on your own, or you use your day-to-day business interactions with customers as means of gathering data. So if you're doing research, you can launch survey, but if you're dealing with transactional data, then your systems, your ERP will be in place, to gather all of this data to you. It's things that you don't have captured in your ERP that you may need some external sources of data to complement. So you may go to research agencies, you may launch your own survey, you may go to your industry regulators to get some of this. But essentially, you need to have framework in place in-house to look through the data and then remove all the noise elements so that you don't have too much of outliers, in your data when you're processing.
Okay, thank you very much, sir, for that response. I believe this would help a lot of business owners that are our audience this afternoon. So another question we have pertains to the net product value that we computed earlier. One of the students had mentioned that the result he got was about 633,000 as against 1.5 that we saw. I don't know if that was a mix-up from his end, but I don't know if you could comment on that.
Yeah, certainly it's a mix-up from his end, most likely. Okay, let me go back to that worksheet. Just 1 minute. People often make that mistake when they are doing NPV. So this is it. Confirm you can see my screen.
Yes, sir, we can see your screen now, sir.
Okay, so if you are using the first method, the first method is like the manual way of computing NPV. And that was where I used this discounted cash flow column or cells. That's this approach here. If you use the one in Excel directly, which is this second method, it's going to be, I said, focus on these cells. Let me color them. These are the ones that will be in your Excel formula. So if you put your, let me go back. I've removed this. So I put NPV. So let's do it the traditional way. So when this dialog box comes out, so it's prompting me here, where is the discount rate? I'll choose this. So where is value 1? I'll just choose these guys as the range, okay? And then that's it. If you do this, you'll get something outrageous. But I know this is not the answer. The answer is going to be this result plus initial investment in the business. And that is what is going to come down to 5.7 million naira. If you had done it this way, you will get the result. If you did not do it this way and you factored in C5 through C10, meaning that you just looked at all of these cells, you will get something which looks like the answer, but it's not the correct answer. So I've reversed that. So this is the correct formula here. If you use this second method, it's a simpler method, depending on what you define as simple. You factor in the discount factors across different timeline based on the formula that we have on the screen, which is this. So that lower element there, 1 plus the discount factor raised to the timeline of the dimension, is going to be your formula. That's the formula that I put in these cells, and it gave me all of these results. And then I divided these values by the corresponding discount factor to get all of this. And then I summed all of this up to get this row, cell E12. And then you can see that regardless of which approach I take, my answers are still essentially the same. So we'll share these worksheets, and then whoever had issues can reach out to me via WhatsApp if allowed, and then I'll be in the position to solve this with the person.
Okay, thank you very much, sir, for that input. I believe this candidate has been able to gather insight as regarding that question. So one last question we have here before we take on questions from the audience, because our time is fast spent, would be what better way can we run survey and analysis without using the traditional method, that is the paperwork, case signing record, as this can be overwhelming and cumbersome? And also considering that most sales and analysis are captured by accounting departments using QuickBooks and SAP.
Okay. Yeah, the easiest way these days is to use online approach. SurveyMonkey is there, Google Forms are there, Microsoft Office form is there. If you have any of these three, you can use. And if you have Power Apps, in-house within your company, if you're a Microsoft shop, you can easily integrate the flow of data from all those forms straight into your analysis platform. So you don't wait till the survey is over before you know what people are saying. So these are channels that you can use these days to, gather data from members of the public, and you can see how things are proceeding on, time, 1 hour, 2 hours, even real-time online. Let me just put it that way. Real-time online, you see data flowing in, and you can base your analysis on that.
Okay, thank you very much, sir. So we'll proceed to take the first two questions, people raising up their hands. That is Paul Oyelere. Mr. Paul, you have the mic, please. Mr. Paul? Okay. While we wait for Paul, Mr. Chinonso Emmanuel, are you ready with your question?
Thank you. Yeah, I'm ready. Thank you. Thank you, sir. Mine is not really a question, it's just a comment. As regards this particular class was really impactful because what I currently do is I'm into supply chain management in the manufacturing sector. And it was really interesting seeing how you were able to optimize, in fact, the way you use Excel to kind of manage the flow of material from production to warehouse and things like that. So if you can make this document available for us, and if there are other advice you can give myself, someone like me that that is into this field, how I can maybe the areas I need to explore, like the Excel, Power BI, and all that, when I'm running my analysis, on all these supply chain analysis, production, and all that. Just your advice and as regards the tools I can use, and if possible, and share with us the document that's really helpful. Thank you.
Yeah, thanks, Nonso. We can talk after the show.
Okay, sir. I don't know if at this point Didactics would allow us to take on either your LinkedIn URL or your WhatsApp contact for those who would like to connect with you.
I think it's up to them to decide. I can give that out via the chat if it is permitted.
Okay. While we proceed, I would like to bring to our notice that the survey link is open now. You can access it on the chat platform to fill out your survey for you to get the recordings of this worksheet. So, Mr. Paul, are you ready now? Okay. Mr. Emmanuel Edward, you can proceed, please.
Okay. I was saying before, when the line cut out, the network cut out the other time, that the way the attendance is being handled is not favorable to most of us that are online. This is work hour. We are on duty right now. We are maneuvering between listening to this program and doing our duty at job. So we are not 100% available on the line. So when the attendance pop out, shortly it will go back. You understand? So if the attendance is going to be by this survey, then let it come on time so that everybody will have access to it. You understand?
Okay. Thank you very much for that feedback. I'm sure.
We will, as well as possible, we'll have the link of this facilitator, because this particular topic, part discussion is very, very important. We need to have more discussion with him. And if it's even form part of our course unit, I think everybody will like it.
Okay, sir.
Because I have thought of this before recently.
Oh, wow. Thank God for this event then. And for want of time, I would like to state at this moment that Mr. Ibrahim, thank you very much for this insightful section. Thank you for teaching us this afternoon about practical ways we can carry out data analytics with the sole aim of decision making, strategic decision making, of course. At this point, we are grateful. Thank you once again. So without further ado, we're going to be inviting Mr. Idowu Adeleke as he takes the next section. Mr. Idowu, you have the mic.
Okay, good afternoon, everyone. Good evening, good afternoon. I must say, special appreciation goes to Mr. Ibrahim for the very wonderful section that we've just had now. And also to our moderator, Mr. Sunday, you did very well in moderating today's section. All right, so I'm here, not for another section, just to briefly speak on Rome Business School. And just like I would always tell prospects, that your learning journey here is not just restricted to the classes, it's also in the webinars like this. And your learning is practical and is of experiential learning. Everyone on this call would agree with me that Mr. Ibrahim has shown value, right, for the 1 hour, 1 hour, 30 minutes that we've been on this section. It's been taking us from the theoretical aspects, a brief of all what it involves, and then to the practical aspects, okay? So for the prospects on this call, this is just, just a bit of what you'll be experiencing in the classes. And the relevance has been shown in logistics, has been shown in marketing, has been shown in sales, it has been shown in all sectors of business, because anything that has to do with data analysis has to do with all sector of business. So thank you very much, Mr. Ibrahim, for this wonderful and very insightful one. So for the prospects on this call, just like Mr. Ibrahim's very last slide, if you want more details on this, enroll into Rome Business School, and then you'll be getting value, a whole lot more value, and in-depth knowledge on this topic and so many other related topics. So thank you so much for your time. Reach out to your advisor if you are yet to complete your admission process. And then for those that are already enrolled, this is a way we actually give extra values to our students. Thank you, and do have a wonderful evening.
Thank you very much, everyone.
Thank you, Mr. Ido, for that remark. And to close on this event this afternoon, can we make welcome Ms. Chiamaka as she takes on the closing remark. Ms. Chiamaka, are you ready?
Thank you so much. Good afternoon, everyone, once again. Thank you so much for this section today. I would like to thank Mr. Ibrahim Ahmed, especially, and also Sunday. Thank you so much. You did wonderfully well. I really appreciate. I think I reached out to you on last week, okay, and you confirmed. So thank you so much for joining. So to every other person on the call, I would also want to thank you for your patience and for staying with us, and also to give some announcements. First of all, Mr. Ibrahim is on LinkedIn as Ibrahim Ahmed. So all of us that are looking out for his details, you can reach out to him on LinkedIn, try to connect with him and try to chat him up. He's there, he's going to answer all your questions anytime, any day. So you can do well to reach out to him and ask your questions, because I saw a lot of hands. A lot of people raised their hands and we couldn't answer their questions or take their questions. So please just reach out to him. He will answer your questions. And also, Sunday Moses is also on LinkedIn as Sunday Moses Ijo. He's one of our students, yes, in data science department or data science program. Do well to connect with him as well. And he's so good with data analytics. So you can also relate with him. I'm very much sure that he's open to questions as well, so he can answer your questions also. And we've also sent out the survey. You can check that on your chat box. Do well to fill the survey. Everyone that is asking for the recording, for the slides and the Excel, we are only sending this recording and slides to students that attended this program and filled the survey. So we wouldn't appreciate someone reaching out to us on chat that we should share the recording to them, maybe privately. So it's only through this survey that we'll share the recording and the slides. So do well to fill the recording. Thank you so much. And on behalf of the Dean of Rome Business School, Professor Ragusa, and every other person in career service, the Director of Career Service, Miss Sarah, Justina, Victor, we thank you so much for joining today. And in absentia, we would like to thank our back-end managers, Francis, Samuel, Vincent. We would also like to appreciate them for always being there for us to organize this event back-end. And we also wish you well, that you spend your weekend nicely. We'll also be having a pre-incubation program tomorrow for everyone involved, because we have registered students for that. So we'll be having it tomorrow by 3 p.m. So for everyone that is registered for that, do well to join the program by 3 p.m. as well. Thank you and have a wonderful day ahead.
Bye-bye, everyone.